We are working out a few problems from compound interest today. Problem is this. A sum of 10,000 rupees becomes 17,280 at 20% compound interest. Interest being compounded annually in n years. Find n. To find out the amount a certain sum, say P, becomes after n number of years at R rate of interest is given by the formula A equal to P into 1 plus the whole raised to n. We've already discussed this in the previous video, whose link is given in the description below. Here P is the principal, R is the rate of interest, n the number of years, and the total amount you get after so many years will be A. Now, what do you have in place of P here? 10,000. Interest is given to be 20%. Number of years, we don't know. Take it as n. See, they have mentioned it as n, so we'll take it as n. And the total amount it becomes after so many years is 280. Now all you have to do is to solve this equation for n. It's an exponential equation. So unless we use a logarithm, we won't be able to determine the value of n here. Anyway, we are not supposed to use logarithm in competitive exams. So how else to go about it? Trial and error is the only way to find out the value of n. Before that, let's simplify this. Take 10,000 to the left side and write this left side just for convenience. I'm writing this first. The whole raised to n is equal to 17,280 divided by, this is actually 1.728. Now the left side is this. On simplification you will get 1.2. Whatever you have inside will get reduced to 1.2 equal to 1.728. Now to find out it, trial and error is the only method. So you can look at the different options given and try out all the numbers. So you may begin with 1.2 raised to 1. Anyway, obviously not equal to 1.728. Put n equal to 2. Again, 1.2 into 1.2 is what you get by putting n equal to 2, which is 1.44, which is not what you see here on the right side. Then the next option is n equal to 3, which means this is what you are going to get. This on multiplication will give you 1.728. That indicates n is equal to 3, which means after 3 years, 10,000 will become 17,280 at 20% per annum. So this is the answer to the question. So we just use basic formula in compound interest in this problem. It's a simple one. Now let's look at the second problem. The second problem is this. A certain sum of money becomes 1,61,051 after 5 years at a certain rate of interest and rupees 1,33,100 after 3 years. What was the sum of money? Yeah, this point is needed because the question doesn't make any distinction between simple interest or compound interest. Since interest is being compounded annually, it's a case of compound interest. Now we know the formula to find out total amount. A certain sum becomes after n number of years. This is the formula to find out the total amount you receive. Now, we don't know the principal here. We don't know the rate of interest. Okay, let P be the principal and R be the rate of interest. Other things are there in the problem. Here in the first case, n is equal to 5 and A is equal to so much. A certain sum becomes so much. So A is equal to 1,61,051. You just substitute that here. So let me write this first. P we don't know. Write it as it is. R also we don't know. And this is 5. And it becomes 1,61,051. Similarly, if you convert the second statement into an equation, you get P again, the same sum. That is the meaning. Same rate. There it is 3 years. And it becomes 133100. So this is the data given. We have translated that into two equations. So as you can see, there are two equations and two unknowns, P and R. So theoretically speaking, these equations are solvable. Now the next step is to how to go about solving it. So solving means actually what? you're trying to get rid of one variable, doing whatever you can. What I suggest is you divide equation 1 by 2 so that p will get eliminated. And using the laws of exponents, here you will get 5 minus 3. And the right side will be 161,051 by 1331,00. This on simplification you will get 1.21. That implies left side is what? 1 plus r by 100 2 equal to 1.21. This implies what? This is a perfect square. This is the square of 1.1. So 1 plus r by 100 will be 1.1. If you want, you can solve for r, but we are not finding r. We are finding p. So what I suggest is you substitute 1 plus r by 100 equal to 1.1 either in this or in this equation. Or better we use the second equation. So substitute that here. P inside 1 plus r by 100, you can substitute 1.1 for that. So you have 1.1 the whole raised to 3 equal to 0, 0. Now this implies what? P into 1.1, the whole raised to 3 is 1.331. So that's equal to 0, 0. This implies P is equal to 1331, 0, 0, 31, 1 lakh. That is the final answer to the question. Rather, the sum of money asked to be determined in the question is 1 lakh. Let's do one more problem in today's session from compound interest. The question is this: the compound interest on a certain sum at a certain rate of interest for the third year and second year are 1,210 rupees and 1,100 rupees respectively. Find the rate of interest and the sum or the principal. Let P be the principal and R the rate of interest. Now you've already seen in my previous video a simple result like this: minus CIN equal to CIN into R by 100. The video covering these basics is given in the description below. I would encourage you to go through that video before taking a look at my solution here. This implies, putting n equal to 2, you will have CI3 minus CI2 equal to CI2 into R by 100. See, what does this mean actually? CI3 denotes compound interest for third year. CI2 means compound interest for second year. So this is basically the difference between compound interest for 2 successive years equal to compound interest for the just previous year into rate of interest. Now, these things are given in the problem. See, they say CI3 is 1210. CI2 is 1100. Again, that's 110 into R by 100. Simplify this. 0, 1, 1. There is a difference between these two, and that's equal to. On simplification, R is equal to 10%. So we got the rate of interest as 10%. And there is one more quantity to be determined, that is the principal or the sum. Now let me extend this logic. CI2 and CI1. That will be CI1 into R by 100. Now CI2 we know 1100. CI1 we don't have. Write it as it is. CI1 R determined to be 10%. Substitute that here. So you will have this. This implies take CI1 to the right side. CI1 plus CI1 into 10 by 100. This is equal to, you might simplify this, take CI1 outside, inside you will have this, and that's equal to, this on simplification will be 1.1 and that into CI1. And combine this and this. Let me write this first. 1.1 CI1 equal to this unit. Now CI1 equal to 1100 by 1.1. This will be 1000. So we have found out compound interest for the first year as 1000 rupees. In fact, compound interest for the first year and compound interest for 1 year, they are the same. Basically, in the first year, when interest is compounded annually, there is no difference between compound interest and simple interest. For the first year, the changes come about from the next year onwards. So this you can take as just interest for 1 year. Now we are asked to find out what sum. We have assumed sum to be, or the principal to be P here, and interest for 1 year means 1, and the rate of interest already found to be 10. So this is interest for 1 year, which is CI1, and that's equal to 1000. This implies on simplification P will be 10,000 rupees. So the sum is 10,000 rupees. So today we have worked out 3 problems from compound interest. If there is any step you are unable to follow, please raise it in the comment section. I will address it there. See you guys in my next video where I'll help you with smart solutions to some more tricky problems of this kind. Bye for now.